Okay, hello again. Um, we continue with the checkpoint that we were doing. We continue with the checkpoint that we were doing. Okay, so question number 29. It says in the show running config, which part of the syntax is represented by running config? So part of you need to know the syntax of a command. Let me see, comment. Let me use my pencil. So with our command, for example, this show running config, what you basically see a Panesco command ratio running config, I think it's let's say it's on a switch. Okay. That command is on a switch named switch one. Then you see something like this. So you have show, then you have run config. That's the command. So they're asking you on the syntax, what is represented by this part? So this part represents the name, the host name. This uh, shows you which mode you are in, the privilege exec, and this one is the command. So this one is the prompt. I hope I'm not getting this wrong. This one is the prompt. Then show is the command. What is this? This is what we call a keyword. Right. Then I think it's just the syntax of a command. I think it was linked in module number 2, I think. Basic end device and switch configurations. 30. Uh, After making configuration changes on a Cisco switch, network admin issues a copy run startup config command. What is the result of issuing this command? Copy run startup. So when we use the copy command, it means we are moving. It can either be the running configuration to the startup config file, or we're moving the startup to the running. So in this example, if we start with running config, it means we're moving files from the running config to the startup config. I think a brief background, Tangraku, in understanding my TPM memories, RAM and NVRAM, the other one being volatile, the other one being non-volatile. So muno domine running config, muno domine startup config. So if you want to move the running configurations to the startup, you say copy run startup, meaning you move from the RAM to the NVRAM. If you want to move from the NVRAM to the RAM, you use copy startup config, running config. And basically, I think in do command at Naya. So what does it do? What is the result of doing this? If we copy the run configurations to the startup configuration, what will happen is the new configuration will be stored in flash memory. Mm, may put a question mark. It might be something. The new configuration file. I want to eliminate answers first. The new configuration file will be loaded if the switch is restarted. The new configuration question mark can be an answer. The current iOS file will be replaced with a newly configured file. We cannot replace the iOS using that. The configuration changes will be removed and the original configuration will be restored. The configuration changes will be removed. No, they won't be removed. So with this command, what we are doing, we are moving what we are currently configuring to the startup configuration so that if we reboot, then whatever we have is now in the NVRAM, which is the non-volatile RAM. Therefore, when we reboot, it will not disappear. If it does not disappear, then probably this sounds more like an answer. The new configuration will be loaded if the switch is restarted. Why will it be loaded? Because we've moved it from the RAM or the running config file to the NVRAM or the startup config file. Right, 31. What command will prevent all unencrypted passwords from displaying in plain text in a configuration file? That's easy. Service password encryption. This one is used to lock the privilege exec. Enable secret. This one is used to lock the privilege exec. Enable this is used to lock the console. Then this one is used to lock the privilege exec as well. All right, maybe a little insight on my answers are A, B, and the tickets are A, B, C, and E. A command enable password and password dash up, and another command enable secret yajo here. These are the commands which are used to lock the privilege exec. The difference between them in encryption, with this one coming with encryption, this one doesn't come with encryption. So if you see my answers A, B, C, and E, my variance of these commands, if I can say. So enable password dash and the secret, though it will represent one X. The second one, excuse me. All right. So the first one, like I said, I think it's an example of this one. Then the second one is an example of this one, meaning password yedu is actually secret password, though password ninge password yacho. So I think my question is ngoda ku confuse and brain, but it's almost the same thing there. All right, question 32. Network admin enters the service password encryption command. What does this command accomplish? Service password encryption, it encrypts my passwords basically. So this command encrypts passwords that are transmitted across the serial 1 links. No, that's not the answer. This one. This command prevents someone from viewing running configuration passwords. This could be something. Let me eliminate. I think you need to use this method as well in answering my questions. Eliminate my answer. I already sure that they are wrong. Then Sarah. So this command enables strong encryption algorithm for the enable. No. Automatically encrypts passwords in configuration files that are that are stored in NVRAM. Provides an exclusive encrypted password for external services personnel who are required to do router maintenance. No. This command, Shanda, in practice, I think in practice, if we were doing my labs, my passwords Ataka which we learned over the course, I think there were 3 or 4 of them. Right. One, demo privilege, enable secret. The passwords that we learned. Let me just go through this. All right, so we have enable secret with your password X, which locks the privilege exec. Then we have the password X in the line console. So let's say we're in the line console. This was the password console. Then if we have another one in the line VTY, it's the same password X. All right, my password is R2R. If you realized, ukaenda kushoran, these passwords always come not encrypted. So ndikaisa password yangu yakanzi Cisco here, then ndoisa password yakanzi class here, ukaenda unoita shoran on the section rine passwords epa line v2 nepa line console, you can see password yakanzi Cisco inge password yakanzi class. These passwords are not encrypted. That's a problem, because if someone views the running configurations, then they are able to see kuti passwords akamira sei. So the command in the service encryption passwords, what it does, rinouya roencrypta passwords like these ones. If you have this command, if you type in that command, then passwords aya paunonoita show run anouya ari numbers and some characters, meaning it's now encrypted. So after service password encryption, this becomes encrypted. Going back on my answers, Edu, we are an answer which makes the most sense. I think then the eliminator I want that this one is left. Answer it here. This command prevents someone from viewing the running configuration passwords. Right, 33. What method can be used by two computers to ensure that packets are not dropped? Encapsulation. Encapsulation is addition of information when we move from one layer to another. Then we have de-encapsulation, removal of that information. So this is not an answer. This does not make sure any packets are dropped, this one. Flow control, I know. Access methods. Access methods is how we get access to our switch or our router. We have access via the console, we have access via the SSH. It is nothing to do with packets being dropped, this one. Then a response timeout. Response timeout, it's when the destination is usually not available. You're trying to send something, the destination is not available. You usually get this response timeout message. But with respect to what method can be used by two computers to ensure packets are not dropped, we have flow control. So flow control is basically where, in simple terms, two devices, device A and B, communicating with each other. If there is congestion, then there is communication between A and B, kuti pane congestion. Kana pane congestion, then if A is the sending device, you know what's going to drop a speed bichana because pane congestion. To drop a speed ikoko, it allows my packets not being dropped because uka push a traffic yakawanda pane congestion, my chances that my packets they get dropped is very high. But uka drop at that speed, then network inoita functional zvinenge zviri nani. So that basically what flow control is. At layer 2, to be specific, there is negotiation between my ports. I think it can be explained based in if you have two my devices, two my switch to be exact. Put this flow control. So if you have two my switch arrow communicator, right, then you have this link in my ports RPI. Then port run speed 1 gigabyte per second. Port run speed 100 megabytes per second. Flow control is these two devices being able to recognize if this port push 1 gigabyte per second, this port will not be able to take in 100 gigabyte a gigabyte per second because it's too much traffic. We can only handle 100 megabytes per second. So what do? We negotiate. So there is exchange of messages. We negotiate. After negotiations, this one reduces its speed to 100 megabytes. Therefore, if we are all communicating at 100 megabytes per second, there is no problem. That basically, I think, defines what flow control is. A bunch of protocols that can be used for that. The end-to-end, let me see. Question. All right, question 34. Which statement accurately describes TCP/IP encapsulation process when a PC is sending data to the network? Encapsulation process when a PC is sending data to the network. Data is sent from the internet layer to the network access layer. Right, let's start with what TCP/IP is. 4 layers. So for TCP/IP, we have the application, we have transport, then we have internet, then we have network access. Right, those are the 4 layers. When we talk of encapsulation, it means we're adding information. When we're adding information, we are moving from there to there. That is what encapsulation is. So this is encapsulation. And when we move from there to there, this is de-encapsulation. Right. So here, which statement accurately describes TCP/IP encapsulation process? Number one, A, data is sent from the internet to the access. Data rikabva kuenda to the access. I think partly that can be encapsulation. So let's have a question mark there. Data is sent from the internet layer to the network access. When a PC is sending data to the network, right? That can be an answer. B, packets are sent from the network access layer to the transport. So transport, this is not encapsulation, that is the encapsulation. So this is not an answer. Segments are sent, okay, yeah. Segments are sent from the transport layer to the internet layer. So from here to here, this can be an answer. So these two can be answers. It just choose a correct from there. Frames are sent from the network access layer to the internet layer. So network access to the internet, this is de-encapsulation. So this is definitely not an answer. How many people do we have? 4. Right. A and C. Which one is the correct answer and why? I can see, I think we have a couple of guys, vandudzo chapter 10, mumwe chapter 7. So chapter 1 to 3, this should be easy. Which one is the answer between A and C and why? Give it a try.
Hello, say.
Yes, Ndugu born.
I think A is the correct answer here because tikutaura nezvekuti it's now data being sent from the internet layer to the network access layer. So no, I'm going for the C. Sorry, I'm going for C. Ninyema segment because tikutaura TCP. So I think C is the correct answer here. We are
All
dealing with segments rather than data really like full.
right.
That's what I think.
You are very close. So to explain this, I think we have to add, let me add, so from, let me do this. I think Regard Vatango explain a little bit about the processing encapsulation and in the TCP/IP. So for TCP/IP, we have 4 layers. So we have the application layer, we have the transport, then we have the internet, then we have the network access. Other things you need to know, if we go from this direction to this direction, this is encapsulation. Then if we go from this direction to this direction, this is de-encapsulation, right? You also need to know about PDUs, product data units. When we're in the application layer, our PDU is called data. Here it's called a segment. Here is a packet. And here we have a frame. That's also where we have bits. Right. So question yedu yabvunza kuti a PC is sending application data to the network. We are on the encapsulation side. So my answers angati now two. The other one tube is a segment kuendesa up. I think that was C. Then the other one let me see. Data is sent from the internet layer to the network access. So data from the internet to the network access. So one answer with the segment here. One answer this is a segment being moved from the transport to the internet. The other one with the data being moved from the internet to the network access. The correct answer is this one. Because as we go through encapsulation, panap, connecting transport layer in a segment. So segment does not move over. Connecting internet in a packet. Packet don't move over, not data. Data run go application. That's where the answer is basically. Your understanding in PDUs could, if we're in this layer, then the PDU is called either data, segment, packet, or frame. Right. So for this question, I think that covers all the processing, encapsulation, and everything. Let me see. All right, voila. So the answer here is C. Why? Because it correctly describes movement ye-PDU segment from transport to internet. When we're in the transport in a segment. However, can I internet layer? PDU radar is data, it's a packet. Packet up. Then that could have been an answer correct as well. All right, 35. What three application layer protocols are part of the TCP/IP protocol suite? Application layer protocols, DHCP is application, this is application, this is application. This one is internet. This one is network access. This one is IP to ARP. This is network access. All right, so my answer to R3, B, C, D. You need to know. I think if you went through our videos, there was much emphasis here. You need to know. Kuti my layers OSI is 7 from the application to the physical. You need to know. My PDUs angle when we're in the application, data, to segment, packet, frame, bits. You need to know there are common protocols. These are very common. DHCP, you encounter this very much. DNS, a lot. These are common protocols. You need to know which layers they belong to. You need to know briefly what that protocol does. ARP, there is a whole topic about ARP, a whole module. DHCP, CCNA2, a whole module. DNS, we don't have a whole module, but it's still a common protocol. Network address translation, you learn about that point-to-point protocol. So you need to familiarize with the protocols in which layers they belong to. Match the description to the organizations. So those are the organizations responsible for standardization. IANA is the one in open IP addresses. So let me see. Let me go by. This organization is the largest developer of international standards in the world for a wide variety of services. It is also known as Open Systems Interconnection, OSI reference model. A, the responsible, which is, I think it is ISO. This is for ISO. Yeah, this is for ISO. So the organization which is responsible for this, for the OSI, is called ISO. Then the organization promotes open development, evolution, and the use of the internet. This is ISOC. So this is ISOC. Then C, this organization is responsible for overseeing and managing IP address allocation. This is IANA right here. Then EIA, TIA, structured cabling. I think it's responsible for mostly cabling. That's where I know EIA, TIA from. It's not there though. So Mansa said, Akadara, you need to know my organizations which are responsible for mostly what we do in networking. Right, 37. Which name is assigned to the transport layer PDU? Transport layer PDU is called a segment. 38. When IPv4 addressing is manually configured on a web server, which property of the configuration identifies the network and the host portion? Is the subnet mask. I think Genius was better. There is a whole module about that one. The subnet mask basically separates this is the network portion and this is the host portion. 38, 39, what process involves placing one PDU inside another PDU? That is what encapsulation is. You take one set of information, you add it into another set of information. The process of encapsulation. What layer is responsible for routing messages through an internet network in the TCP IP model? That layer is called the internet layer, layer number 3, dominant routing. Then 41, for the TCP IP protocol suite, what is the correct order of events when a telnet message is being prepared to be sent over the network? All right, number 1, a IP header is added, Ethernet header is added, TCP header is added. All right, so here, what is the correct events when a telnet message is being prepared to be sent over the network? All right, when a message is being prepared to be sent over the network, a communication need always, inotangira in the application layer. So this is application layer. You zika down the layers, ushikashika to the physical layer. So kuno prepare information so that it can be sent over the network. That's where the user interface is. That's where the user interacts with the network. All right. So kanatitangira kumsoro application layer. What relates to the application layer panam is D. So this is number 1. Telnet formatted data is provided to the next layer. That is where data formatting is done. I think we mentioned something to do with that in the presentation layer. Okay, PANAP, by the way, plus TCP IP. So here we don't have physical, we have network access. So from the application to the network access. Application layer and dominate data formatting, putting it into a correct format. Then from there, takwenda transport dominate TCP header. So this is number 2. Then Ethernet, from transport takwenda internet dominate IP header. So this is number 3. Then Ethernet header number 4, network access. I think it's just a matter of knowing good layers are in the TCP IP yakamira say and what are they responsible for. This is easy. You will not see questions like this in your final exam. If you do, make sure. I think these are very easy questions. This is introduction. Which PDU format is used when bits are received from the network medium by the NIC? So, Malaya's Edu application, physical or network access. So, when bits are received from the network medium by the NIC of a host, right? Network medium, can I talk to network medium? We're in the physical layer, right? So when we receive information in the network media and we move it to the NIC, but nenda ku NIC takutenda layer number 2. So the format that to receive our call is a frame. Which PDU format is used when bits are received from the network exactly? So we are receiving bits from the physical layer, and they're going to the next layer, which is the layer number 2. That's where the NIC is. PD rendering it frame, basically. All right, 43 refer to the exhibit. All right, 43 exhibit Habana. Think they needed to be an exhibit. Let's go to 44. Which method allows a computer to react accordingly when it requests data from a server and the server takes too long to respond? I think I'm referring about response timeout. So if the destination network or destination device is not available, then it needs a response timeout. Encapsulation, that we explain out chief flow control, access methods. I think it's just a matter of knowing which each of those things is not a way. By definition, response timeout answer there. A web client is receiving a response from a web page. So we have a client, then we have a server. A web client is receiving a response. So transmission ilubva server kuenda client. From the perspective of the client, what is the correct order of the protocol stack that is used to decode the received transmission? So from the perspective of Knock, patino receive a message from here, inosvikira which layer? Inosvikira in the lower layers. So my layers head again from the application to the physical. Message inosvikira this layer. Then yotanga kukwira kusvika application layer. So if I look at this, chinotanga pasi apa is definitely not HTTP, because HTTP application layer protocol. Ethernet inokwanisa kuita, Ethernet inokwanisa kuita, HTTP ino yaiti. Then tikabva paEthernet, where do we go? We go to the third layer, mune IP. So this one is the correct answer, I think. Ethernet, TCP. You don't go from layer 2 to layer number 4, TCP. So this one is not an answer. Okay, 46. Which two OSI model layers have the same functionality as a single layer of the TCP IP model? Choose two. Same functionality. So my layers are the same functionality. Can I true compare TCP and OSI? Yeah, let me do this. TCP with 7. So OSI, OSI not application, presentation, session, transport, network, data link, then physical. Then the other one, so this is OSI. Then TCP in a formal layers, application, IoT transport, the internet, the network access. Right, so my layer anobatana, these two layers represent one access, network, yakafanana internet, transport, yakafanana transport. These three, dzakafanana application in terms of functionalities. So tikadzoka answer kwedu, I think is the data link in the physical layer. Kana iripo, of course, iripo. So our answer is this one and this one. All right, 47. At which layer of the OSI model would the logical address be added during encapsulation? Logical address is added in the network layer. We have two types of addresses that are the logical, they are not IP. Then we also have the physical, they are not MAC address. So this one is in layer 3, this one is in layer 2. So layer 3 is the network layer. Dopamine logical address. All right. What is the characteristics of a multicast message? Multicast message, those are delivery options, unicast, multicast, broadcast. Unicast, you are sending to one device. Multicast, you are sending to a group of devices, but not all devices in the network. Then broadcast, you are sending to all. So by definition, multicast sent to a selected group of hosts. This can be an answer. Sent to all hosts, no, must be acknowledged. Single destination, our answer is A. Simple. Which statement is correct about network protocols? Network protocols define the type of hardware. Network protocols are rules that define or govern how communication is done. Network protocols define the type of hardware that is used and how it is mounted. Nope. They define how messages are exchanged between the source and the destination. This can be an answer. They all function in the network access. No, we have protocols in the application, in the transport. In every layer, there are protocols. They are only required for exchange of messages between devices. No, they are required every time you are communicating. So I think our answer B sounds like the answer. Question 50. What is an advantage of network devices using open standard protocols? Open standard protocols allows for, I like the word, what's the word? Interoperability. I like that word. We're having open standards interoperability. I like this word. My standards allow us to have interoperability where different vendors can be able to work together. Question 50, I can see less than 1 minute. Use the same link. I think to consolidate that Singatak farm by a bit fast here. So join using the same link so that we finish the last 20 questions we have.